So we're looking at data analysis question 7, and the key point in this, when you read this question, is that we're trying to work out whether some subjects are the students going to get high achievement in, and to do that they need to be in the top 10%. So we've got 4 subjects: Maths A and B, Physics and Chem. We're being provided with the mean, standard deviation and their score. We've also talking about the student scores normally distributed. So that means we can use Z, the Z score, so Z equals X minus X bar over S. So where S is your score, X bar is your mean, and that's your standard deviation. Okay, and how we use that is, for example, if I've got a Z score less than 1, it means I'm in the top 16%, which means I'm not in the top 10%, or at least, but if I'm a little bit below 1, it's definitely not in that top 10%. So that means not in top 10%. Whereas if I've got a Z score of 2, that means I'm basically in the top 2.5%, above 2. So that means for that one, in the 10%, in the top 10%. Okay, so that's how we can use that here. All right, so what basically have to do is calculate the Z score. So I'm going to go Z equals 80 minus 69. This is for Maths A divided by 12. That's going to give me a value of 0.91. If I do Maths B, I'm going to get 85 minus 68 divided by 8. That's going to equal 2.1. The next one for physics is going to be 81 minus 69 divided by 13. That's going to give me 0.92. And the last one for chemistry, it's going to be 81 minus 62 divided by 9. That's going to equal to 2.1. So what we can see is I've got 2 of these above 2, so that means they're in the top 10%, whereas the other 2 are not. So my answer in this case would be C. Okay, so in this case, this is Recursion Financial Modeling question 21. So somebody wants to invest 250,000 in an account that pays interest rate of 3% per annum, compounding monthly. Makes additional payments of 250 each month into their account. The value of the account in dollars after n months can be modeled using this recurrence relation. Now, you could, for this type of one, you can actually work that out and just put in your calculator and just go sort of enter until you do however many times you're going to get above 500,000. I think the easiest way, so even though it's asking a recurrence, I would actually use Finance Solver, because that just makes your life a little lot easier. And how you would do that is, what you're going to do is your after n, your 3% comes in there, and so because you've got that, your principal value is, because you're investing, you're putting the money in, so it's going to be the minus in front of the 250,000. Your payments, again, you're paying extra in, so that's going to be minus 250. And your final value, so when you reach 500,000, would be your final value. And once you do that, that's going to get however many payments you've got. So you're going to calculate your payments. That's where you're after that n. And what that means is there's basically 216 payments. I did say 216, but as you can see, it's 215.867, etc. So if I divide that by 12, I get 17.98. Now the question says the balance of the account first exceeds, so it's going to be above 500,000 at the end of the year. And as we can see, by the end of the year 17, it's going to be above 500,000, because it's 500,000 just before year 18. So therefore, by the time it reaches year 18, it's going to be above. So it's by the end of the balance at the end of the year, I would say the answer to that one is 17. Now, let's see if we'll find out if that's correct or not, but that's how I would do that question. All right, so we're looking at recursion and financial and modeling question 24 now. All right, so in this case, Victoria has borrowed 40,000 to go on holiday. The interest on the loan is charged at 8.3% per annum. They intend to repay the loan over 4 years with 48 monthly repayments. After the 47 equal repayments of that amount, he finds, so after that amount there, he finds that a small adjustment to the final repayment is required. So I'm just rereading it again, I'm aware of that. Now, here's the thing here. You're gonna have to use Finance Solver, and I would use Finance Solver basically twice. So the first one is when you do 47 payments. So the 47 payments allows you to work out what's left in that last repayment. And so I've put in N for 47, then I put the interest rate, the principal value, because you're told it was 40, you're told their payments is 982 and 16, and your final value is 975. So it's basically saying your payment is 982, but your final value is 975. Now, when you look at, if you actually get the difference between these two, oops, I always don't do very well on doing those arrows properly. Okay, you'll get, in this case, there's 970, you'll get the difference between that of about $6.78, okay? Now, so that means I'm going to rule out these two straight away because that's after 47 repayments. That's not your last repayment, so I'd actually get rid of A and E straight away based on that. So then what I would do is I would actually use that final value, because remember, you're still going to get interest paid on this. So it's not that literally that difference there. So what I'm going to do is I'm going to have one repayment and I'm going to have the same interest rate. I've taken that final value and put it there because that's what I've got left. I've said my final value is 0 because I'm paying it off in that last payment. And that's how much I'm going to pay in that last repayment. And so the difference here is between 982 and 16, that's what you've been paying, and that's that. And this one here is 982 and 13, so you're paying 3 cents lower. So I would go B on that one. So now we're looking at matrices question 2. And so let's consider the following matrices. How many of these matrices are diagonal matrices? So let's have a look at what a diagonal matrix is. So diagonal matrix is a square matrix, and they're all square matrices that only has non-zero elements, that has only non-zero elements on the main diagonal. So this is the main diagonal and only has non-zero elements on that main diagonal. So if I'm looking at this one, these options here, this is the only one that has non-zero elements on the main diagonal. Okay, so therefore my answer would be B. So let's look at question 4. Okay, so this one takes a little bit more thinking involved here and being aware of some of the rules you need to follow. Okay, so let's have a think about, you've been told there's a permutation matrix P and it's been given in that form. Now, you've got a column permutation and a row permutation, and it's important to understand the difference. So if I've got, for example, I'm going to use QP. Q's whatever matrix is, for example, it's that one there. But just for the moment, QP means that if I wrote A, and then those are where my elements are, the I and J, what it means is column I moves to column J. So if, for example, that's written as A13, that means column 1 goes to column 3. All right. So that's a column permutation. Row permutation is written as PQ, and that, so if therefore I've got the same formulation there, it means row J goes to row I. So in this case, your row, so if you've got A13, that means I'm going column 3 goes to column 1. All right. Now, if I look at that form there, I've got my permutation in front of my matrix. That corresponds to a row permutation layout. So I'm not going to do a column permutation, I'm going to do a row permutation here. Now, keep in mind that I can rule out 2 of these straight away. I can rule out this one because it's got the numbers aren't going to be appropriate for a permutation matrix, and same here. Okay, so I've got 3s and 4s and stuff like that. Don't need that. So let's have a look at this one here. So that means I've got 3 options left. So let's have a look. So let's have a look and go, I'm going to call this 1, 2, 3, 4, 5. So I'm doing that for a reason, because what it says is M2 as it contains the same elements. So this is M1, so now I want to do M2, but the elements are ordered with the largest value at the top and the smallest value at the bottom. So basically, if I redrew that, it's going to be 25, 15, 12, 9, and 3. Okay, see, let's just change colors here for a moment, just so it's really obvious what I'm looking at. 1, 2, 3, 4, 5. Oops, that should be a 4. And let's give these some numbers here. 1, 2, 3, 4, 5. Okay, so let's have a look at what that means. So for me to go from 25, so from row, so 25 here is row 3. So for me to, so if I put 25 here, actually, let's again do a different color. 25, let's actually just go 25, 15, 12, 9, and 3 here. Now, for me to go from 25 in M1 to 25 in M2, I'm going from row 3 to 1. So I'm going to go 3 to 1, and 15 I'm going to go 4 to 2, 12 I'm going to go 1 to 3, 9 I'm going to go 5 to 4, and then number 3 I'm going to go 2 to 5. Now, the reason I've done that is, what it means is, this is what we're talking about here. So if, for example, row 3 to 1, that means that first part needs to be A13. So I need to find a 1 in A13 and try to match that. The 15 would be A24, then A31. So I haven't lined them up very well. My apologies. Let's do a better job of that. A13, A24, A31, A45, and A52. Okay. All right, so what I need to look for is, do I have, in this case, do I have a 1 at A13? So it's so when I look at that, it means row 1, column 3. Do I have a 1 there? Row 1, column 3. Yes, I do. Yes, I do. Yes, I do. Okay, so I'm not sure yet. Let's go to the next one. So we've done that. A24. So if I then do A24, I go 2, row 2, column 4. No, I don't. A2, I have column, do I have that there? No, I don't. Do I have one there? Yes, I do. And in, for example, so that's that one there. Row 3, column 1, I have a 1. You pretty much know the answer now is C, but I'm just sort of want to show you quickly the other ones. 4, 5, row, column 4, 5, and then row 5, column 2, and that would be the answer there. So the answer in that case would be C. Okay, so we're looking at question 6 from matrices now. And so we're told that this can be represented in a 4x6 matrix. This one here is going to be a 6x2 matrix. So basically what you'd be doing, if I call that V and W, it's basically V times W, and that's going to be a matrix of some sort. Okay. So what you need to consider here is what each part's doing. So if I've got the family here, so imagine if, let's just put, so put that there. What I would be doing if I had it in like my 6x6 matrix there, or my 6x2 matrix there, what I do is I'm going to multiply those bits. Like I'm going to go 1 times 10, 2 times 0, 1 times 4. That's where I'm getting the numbers for these from. 1 times 0, 0 times 12, 3 times 0. And you're going to add those. But that will give you family 1 for the adult. Then you'd go so that's on that column there, this column here. Then I'll do the same for family on this column, which is C. Then I work out the cost. Now remember, the zeros here in that adult one are basically to remove the child from the equation. And then when I do the child one, I've got a zero where the adults are, therefore that removes the adult from the equation. So basically what you're doing is, of the options you've got, it's all the adult tickets for each family, all the adult tickets for each family, and all the child tickets for each family. So that's what's the total cost for the adult tickets. So when I get that value here, okay, that's what I'm going to get. Sorry, when I get my, so what I should have said, so if I did that, I'm going to get a 4x2 matrix as a result. Okay, then if you went 4x6 times 6x2, you're going to get a 4x2 matrix as an answer. All right, so that's what you do for that question there. Okay, what we're looking at here is question 7 for matrices. And as we can see, we've got some information about all employees at a large company work at these 4 locations. And the table below shows the number of employees at each location on every Monday. Okay, so we've got those numbers. That'll become a matrix in a moment. But for the moment, we've also got a transition diagram here, which we can convert into a transition matrix. And because it goes level L1 to L4, so locations, I'm going to have L1, L2, L3, L4, L1, L2, L3, L4. Oops, I always write like that. L4. Okay, so in these ones, what you've got to look at is it comes from here to here. Okay, so what I mean by that is L1 to L1 is 0, is because it doesn't go back to it. So I'm going to put a 0 there. If I go L1 to L2, I'm going to 0 because I can't go in that direction because that's that part there. So again, I've got a 0. Now, if I go to L1 to L3, so that's that one there, I have 1. So I'm going, it's sort of like that. You're going that way and then that way. So you're going from to that number. And then for L4, L1 to L4 it's 0 because I can't get there. There's no linkage there. Okay, so that's what I'm doing with that there. So what I'm going to do is I'm going to fill these in and then come back and go through it so I don't spend too much time going through it. Okay, so you see, now I've filled it in. So for example, that 0.7 and 0.3, just to give you an idea, it's L4 to L1. Again, I can't do it from before. L4 to L2, that's there, a 0.7, because again, it's going in that direction. And if you have a look, and that's same for L3, and then there's nothing between, there's no L4 to L4. L3 to L3 has a 1, as shown in the matrix, because it circles back to itself. Okay, so that's how you can create that transition matrix from a transition diagram. You'll notice that as I go down that column, the values are all equal to 1. Now, what I need to also add into this is this part here, because that's the part that's going to change each day. So what I'm going to put in here, L1 up the top, I'm going to put 80, then I'm going to put 75, then I'm going to put 60, then I'm going to put 50. Okay. Then what happens is I've done this 3 times and I'll go through it. I'm going to just put the answers up here. And so this here is Tuesday. Because the reason I've done it 3 times, and I'll explain what I've done there, is because I've got Tuesday here, 2 Wednesdays and a Thursday as potential options that you have to work through. And the reason what I've done is this is on to get to Tuesday, I've done the transition matrix times the Monday values. And that gives me this. What this is showing is that this part here is 0 only at L4 on Tuesday. Do I have on Tuesday, do we have no employees at location 2? On Tuesday, no employees at locations L2 and L4 only. So it's not, because it's only at L4. Let's now go to Wednesday. All right. Wednesday, what I've done is I've taken this value here and put it there because that's what I'm going to move to next. And then from that, I get this value here. So that's my Wednesday values. And what I see here is 0 at L2 and L4. So if I look at my options on Wednesday, there will be no employees, so it can't be that. On Wednesday, so I've crossed out those two. On Wednesday, there will be no employees for locations 2 and 4 only. So I would be going with that as my answer there. Now, for example, if I looked at Thursday, and again, I've done the same thing and move that across there and then calculate it. I've got 0 at L1, 2, and 4. My only option was L2 and 4, so it can't be that. So the answer in this case is Wednesday. So the answer would be D. Okay, so as we can see here, this is for question 8 networks. A company builds caravans. The building project for the Holiday Fun Caravan involves 12 activities shown in the network below, and it's got their completion times. Then they have another model that comes in called Sunny Life, and that is modified such that activity D is no longer required and there's a new activity added. It has a duration, that's called activity M, has a duration of 2 hours. It has an earlier start time of 17 hours and a latest start time of 18 hours. And it's asking you if the minimum completion time for the Sunny Life Caravan will be the same, basically, or different to the Holiday Fun. Now, what I've done is here is I've put my nice little the little things on top so I can quickly go through this part here. And that means when you do this, I'm going to start off with I'm going to go 0, and then I'm going to go 5, and then I'm going to go 4. Then I'm going to go, well, I can do 6, but it's not quite, because I can go from B and D. So B will give me 6, D will give me 7, because I'm going to 5, and then 2, 7. So I can actually have 7 there. And the reason I'm just going through this because you need to know what changes, when the changes are made, what they're going to look like. So 5 and 7 is 12. Therefore, coming to here, I've got into this one, I've got I, so that I and F. I is going to give me 20. F is going to give me 7 plus 8 is 15. So I'm going to go 20. When I come into here, I've got G and H. And G, so again, as you know, you picked out the highest ones because you need both of those to finish. And say in this case here, 20 will finish before I needs to finish. So to move forward to J, activity J, you need to finish I and F takes 20. So the earliest start time for J is basically 20. That's why you're working it through like that. G and H will give me 14. And G will give me 7, 11 will give me 18. Be careful you don't do 6 plus 11 there and give you 17, because that will not be correct there. Okay, and then we come up to here where I go J and, oops, that's a J and K. J would be 20 and 4, so it'd be 24. And the next one here for K would be, so that should have been 18. 18 and 7 would be 25, so the answer is going to be 25 there. And then plus 3 would give me 28. I like to use different colors, so if you're doing this exam, I suggest you use different colors. 28, go back here, minus 3s. So now what we're looking for is the smallest number when we have to bring them together. So 25. 25 minus 4 is 21. And if I go up to there, I'm going to have, that's going to be 13. Now this one I can have E and D, so let's come back to that in a moment. Come down here, 25 and 7 would be 18. And then what we can look at here is, coming in here, I've got F and G. Sorry for my really bad writing here. 21 minus 8 is going to give me 13. And for G, it's going to be 7. So I put 7 there. 7 minus 2 would get, so from D here would be 5. And then 12 minus 7 would be, sorry, where did I get that? so 13 minus 7 would give me 6. So I'm going to put 5 there, and I'm going to have a 0 here, but it's basically A, B, C. So this is the way I do these ones. I know I've seen people do slightly different. 1, I'm going to put 4 because I know the answer to this one. 18 minus 10 would be 8. A minus 4 is that. So this is where you're basing it from. So you might not have to go into this exact detail, but it's good to just go through it to make sure you get that. Now, that is for the holiday fun. Now we've got the sunny life one here, and you will notice that I've actually removed, there it is, I've removed D. And what that means is if I go through, and I'm not going to do every step in this case, but what I'm just going to go 0, 5, 4, 6. So that was 7 before, remember? So this now becomes 17. That is 12. This is still 20. Okay. This is still 24, and this is 27. Okay. So at the moment it's 27. So in the question you might have come up and go, but where would M go? Just to make sure why I'm saying that's 27 here. M, the earliest start time would be 17. This is the only spot where I can have an earlier start time of 17. And if I put a line from here to here, now if I started, say I've kept that 27, so that's 27 there, come back here, get 24, this becomes 20 here. Now what happens is if this is M2, that means I've got M and 20 minus 2 would be 18. And I get 24 minus 7 is, for K, would be 17. So I'd actually put 17 there, but you notice that for activity M, it would be 18 hours. And so my M would go in here, and I can't put anything else. So basically, if I look at that, the earliest completion time for the Sunny Life caravan would be 27. So it's 1 less hour than a holiday fund. So in this case, I would say the answer is B. Okay, that is those questions. Now, you wouldn't have to necessarily do it as long for this in the exam. You don't have that much time, but that's how I would sort of picture how you'd have to think it through a bit.